Can you all hear me? There's literally hundreds of you. But anyway, my name is David Macmillan, and I'm from a company called Grundfos. Have you all heard of a company called Grundfos? And I actually live here in India. I have the pleasure to live here in India. I have done for the last 1 or so years. But today, I'm going to make a promise that I'm not here to talk about Grundfos, or I'm not really here to talk about how good Grundfos are, or because I'm with colleagues from the pump industry. So here I'm championing the pump industry and not having shots at our competitors, because we are all in this together. So I'm mainly going to talk about that, and it's a pleasure to be here. There's not many of you here, but maybe that's a good thing, because maybe that means that you're really committed to this industry. You're either in a manufacturing company who makes pumps, you're a consultant, you're a contractor, or you're someone who puts pumps inside buildings. So it's a real pleasure and an honor for me to be here. And the first thing I have to say is this is an industry that pretty much all of our friends and our family know nothing about. Let's be honest, when I first got into the pump industry, trying to explain to my friends what I did was quite a difficult task. They were in pharmaceuticals, they were in technology, they were in finance, they were in automation, automotive. And when I tried to explain what I did for a living, it was quite difficult, because people don't really know what we do. They don't know. They actually, by magic, when you open a tap in an apartment block, water appears by magic. And when you turn the AC on, cool air appears by magic. And when you flush the toilet, wastewater disappears by magic. So 90% of the people that we interact with don't really know what we do. And maybe that's a good thing, because maybe we are the unsung heroes. Because actually, think about buildings if they didn't have pumps. Think about a skyscraper. I come from the Middle East. I was 4 years in the Middle East. And think about the skyscrapers in Dubai or the skyscrapers in Mumbai without pumps. Think about without plumbing, HVAC, without firefighting, without dosing and disinfection. It wouldn't be a very good place to be inside a building. So this is one of the things that no one really knows what we do. Even when we say the company name Kaloska or the company name Grundfos or the company name KSB, there's a very small part of the world that really understands us. So actually it's good that you're here, because that means you're passionate about something. So thank you for being here. What I want to talk about today, and I'll only take a few minutes, is what does the future look like inside buildings? And let's be honest, pumps have been going since, have you ever heard of a person called Archimedes? Archimedes actually invented the first pump, and there hasn't really been too much change. We can all claim to make great products, but let's be honest, we're at the pinnacle of technology in terms of pump efficiency. We can make some efficiency gains. We can turn a split case pump from 88% efficiency to 89% efficiency, or 90% efficiency. But we cannot go from 89 to 99. Let's be honest, that's a long way. So where can we get efficiency gains? Because this is what it's all about inside buildings. What is it all about in buildings? Buildings in the future, they'll be more intelligent, they'll be more sustainable, they'll be green, they'll be smart. And they'll use as little energy and consume natural resources as little as possible. And that is the future of buildings. How can the pump industry support energy efficient buildings? It won't be with more efficient pumps, I can tell you, because it will only get us so far. Where we will get the biggest gain in technology and efficiency is around motor technology. So motors will become more efficient. I'm sure you've heard of maybe the European legislation, or maybe even here in India, where we have the new IE ratings for motor efficiencies. So we're upgrading motor efficiencies. Also, motors are becoming more intelligent, variable speed drives, built-in variable speed drives. So the thing that will drive energy savings inside buildings with the pump industry is largely going to be slight efficiency increases in pumps, using the best pumps, using the best efficiency motors available, using variable speed drives, and all of that cannot do anything unless you actually use intelligent controls. So unless you actually use intelligent controls, you cannot make energy savings. And I want to give you a real example, not in the pump world, but in the real world. If you go out now and buy the most efficient car in India, I don't know what the most efficient car in India, but I can guess it's quite efficient. I don't know. Let's say the Toyota Etios as an example. You're making a commitment to buy an efficient car. But if you drive that car in first gear for 60,000 kilometers, you're not using it very efficiently. So it really doesn't matter if you go and buy the most efficient products and then use them inefficiently. It really doesn't matter that you bought the most efficient products. You have to buy the most efficient products and use them as wisely as you can. So the examples that we can say is variable speed drive, and I'm sure my colleagues here will talk about variable speed drive later. But just let me give you a hint. Buildings are dynamic. They change. They change from day to night. They change when people come and people go. They change from summertime to wintertime. Although I live in Chennai, there is no wintertime, let's be honest. It's only summertime and very hot summertime, and then rainy season, and then summertime again. So buildings don't change much in Chennai, but they change around the world, let's be honest. They go hot, they go cold, it's night, it's day. So they're dynamic. So solutions have to be dynamic. Solutions have to change. You cannot have fixed speed pumps anymore because buildings are not at 100% capacity 100% of the time. People come, people go. Airports, schools, office buildings, homes, apartments. So this is why we need intelligent solutions, because buildings are dynamic. So that is kind of my last words. And all I will say now is if we use buildings more efficiently, we change behaviors. One of the things I'm quite surprised about, I came from the Middle East in the last 5 years and also India, the temperature inside certain buildings is too cold. I'm wearing a jacket not because I want to look smart, it's because it's actually a little bit cold when you come into some of these rooms. So it's not just the solutions, it's also the behavior. You don't need air conditioning in Tamil Nadu at 22 degrees. 26 degrees would be okay. It would make you feel more comfortable. So not only do we have to change to go the most efficient solutions, we have to start changing behavior. Increase the temperature by 1 or 2 degrees makes a huge difference on energy savings. So we have to start changing behavior. And let me give you one final example. In a pump system, the affinity law, has everyone heard of something called the affinity law? If you're engineers, you've probably heard about it. And the affinity law says that when you change speed on a pump, the flow goes down proportionally. The pressure or the head comes down to the power of the cube, and the motor power comes down to the power of 8. So that basically broadly says if we can reduce a pump speed by 20%, so that's from 50 hertz to 40 hertz, we would save 50% in energy. So just think about that. A 20% reduction in speed is a 50% reduction in energy. So when you turn your air conditioning up by 2 or 3 degrees, the pumps will not need to work as hard. They can slow down and they can become more efficient. So that would be my last words, and hopefully that can pass over to some of my colleagues who will come up next. So thank you for listening, and I look forward to answering some of your questions. Thank you. Who's next?